All right, to better understand this problem is to realize that secant is actually the reciprocal of cosine. So secant equals 1 over cosine. So what happens in the graph is that secant is actually going to be writing the cosine graph. So to me, the easiest way to draw a secant function is to draw a cosine and then draw the secant on top of it. That's that's how I do it, in order to avoid mistakes. So what I'm gonna do, instead of doing this one, I'm gonna do just the basic one. Compare the cosine, a basic cosine, and a basic secant, and then go back and do it. So let me do a basic cosine. I'm gonna do it in blue. So y equals cosine of x, because that's your basic cosine function. So you know the period, if you remember the period when the x has no coefficient, period is going to be 2 pi. And the amplitude, and it's understood that coefficient is 1, so the amplitude is 1. So here is 1 half, and here is 1. Well, I'm going to do this one at just 1 right there. 1 is right there. Okay. So again, first thing is you mark your quarters. So once you have your period, you divide it by 4. So 2 pi divided by 4 is going to be pi over 2. So again, our basic function, we start at 0. So first quarter is pi over 2. So that's pi over 2 right there. And then we go another pi over 2. So that's 2 pi over 2, which is pi. And then I do another pi over 2, which is 2 pi over 2 plus pi over 2. That's 3 pi over 2. And then finally we have 4 pi over 2, which is 2 pi. So again, 2 pi is the period when we have no coefficient in front of x. And again, if you remember the cosine function, we start cosine of 0 degrees, because this is 0 degrees right here. So cosine of 0 degrees, you know it's 1. And then if you know your cosines, you will find out that the wave is actually goes through the first quarter, and then on the halfway through, it goes to the negative amplitude, to -1. So it's like right there. On the next quarter, it goes back to 0, and then finally at the last quarter, it ends up at the top. That's your basic cosine function. Now, the secant function, if you know your cosine function, the secant function actually rides on top of it. But what happens is, remember, pi over 2 is 90 is at 90 degrees. So on your unit circle, pi over 2, it's right here. So x equals 0. So cosine of pi over 2 is actually equal to 0 because x equals 0. So secant is the reciprocal. So when you do 1 over 0, then you're going to have an undefined. And that means we have a thing called asymptotes. Okay, we have asymptotes. So here we're going to have an asymptote because pi over 2 is cosine is 0. So if you want to do the reciprocal, which is the secant, then you're going to have an undefined. So that means an asymptote. So what happens, I'm going to draw the secant in red. So what happens, the secant is the opposite, so start going the opposite way. But once it reaches 0, it says, that's undefined, so I can't cross it. So it's just an asymptote. And same thing happens at the other. Notice the key points here. So the first point is the very top, the peak here, and the vertex of the valley here. Same thing happens. It just starts going the opposite way. And it approaches the asymptote. Same thing here. Remember the unit circle? When you have 3 pi over 2, so this is pi over 2. Then 3 pi over 2 would be the opposite side. So we have pi over 2, 2 pi over 2, 3 pi over 2. So we got the same situation at 3 pi over 2. So at 3 pi over 2, that means we have another asymptote at 3 pi over 2. So let me do it in a nicer line. So at 3 pi over 2, oh, not there, it's this one right here. At 3 pi over 2, we have another asymptote. We have another asymptote. And again, your secant tends to go the opposite way because it is a reciprocal, but it never touches the asymptote. Same thing here. Tends to go the opposite way. So that's that's one period of the secant. Notice we have this red one right here, and then this red one right here, and then this red one right here. So that's the behavior. So, like I said, it's easier if you draw your cosine first, and then notice when the so this is your cosine. Now, when your cosine intercepts the x-axis, that's your asymptote. When the cosine intercepts the x-axis, that's where you draw your asymptotes. And then on the peak and valley, just go the opposite way. Go the opposite way. You know, so it forms like a V. Yeah, that's how you can remember to do this. All right. So remember, at the peaks, at the vertices, that's when you start drawing your secant. And the asymptote goes where the cosine intercepts the x-axis. So let's try to do the problem now and see if we can come up with the same thing. And then we can actually go to the graphing calculator and check our work. Okay, so the amplitude in this case, so the amplitude is 1/2. Period is 2 pi, and the phase shift is actually negative pi over 3. All right, so let's start working. So first thing, we divide our period by 4, and we found out in the early explanation that pi over 2 over 4 is, 2 pi divided by 4 is pi over 2. So pi over 2. That's what we're going to be adding to mark our quarters. But we're going to start at negative pi over 3. So I'm going to mark my negative pi over 3 right there. All right, so So the phase shift marks the beginning of our graph because we only want to graph one period. So this is going to be the beginning of our period. So from pi over 3, the end of our period is going to be 2 pi minus pi over 3. Okay, one way you can do it, if you want to avoid calculators or your, calculations on paper, what I do, I convert this one and this one to a common, a fraction with a common denominator. So I can turn this one into sixths and I can turn this one into six. So this one into six would be a 3 pi over 6 because 3 over 6 is 1/2, so we got 1/2 here. So I converted this one to 6 and I can convert this one to 6, so this one would be 2 pi over 6. Okay, so I'm gonna mark our periods now. So negative 2 pi over 6, I'm gonna add 3 pi over 6, so just count 3 squares. So that's count 3 squares. So we got 1, 2, 3. So it'd be like right there. So it would be like pi over 6. Negative 2 plus 3 is 1, so it's pi over 6. So I'm going to add another 3 pi over 6 to this one. So 1, 2, 3. So it would be right here. So that'll be 4 pi over 6. But if you simplify, we do 2 pi over 3. And then I'm going to add another 3 pi over 6. So 1, 2, 3. So I have 4 pi over 6 plus 3 pi over 6 would be 7 pi over 6. And then I'm going to add another 3 pi over 6. So now I would have 10 pi over 6. And so if I simplify, it would be 5 pi over 3. So now it looks like I have my 4 periods. So that's, 4 quarters. 1, 2, 3, 4. So I got my 4 quarters. And then I draw my cosine. That's pretty easy. So like I said, I have 1/2 here, and then I have 1 here. And so our amplitude is actually 1/2. So it's going to be right here. So I'm going to start right at pi over 3, which is going to be right there. And we start our phase shift. So I'm going to do again the cosine in blue. And so the cosine function starts, at the beginning, starts at the top, and then goes through our first quarter. I guess so. There's a negative half, and then it goes to bottom there, through there, and finally ends up right there. So again, remember the asymptotes have to be at the x-intercept. So we draw our asymptotes at the x-intercepts. So the first asymptote is going to be right there. And just kind of cut it a little bit. And our second asymptote is going to be drawn at the other x-intercept. Boop. I wanted to cut it. So, two asymptotes. So, we have our cosine curve and we have our asymptotes drawn. So now we draw our secant. So our secant goes in the shape of a V, approaching the asymptote, and so it's going to be like this. And remember, there's another. Do this at the peaks and at the valleys. And same thing here. It goes in a shape like a B, shape like a B, and shape like a B. So the red is our secant function, and I hope you understood my explanation. It was kind of a lengthy explanation, but well, actually I'm not done yet. We're gonna prove this by going into a graphing calculator. So we're gonna go to Desmos.com to get a graphing calculator, and I'm gonna graph a secant and a cosecant of the same function right there. So it's half secant of x plus pi over 3. So let's go to Desmos, and it's actually right there. I did it already, so I'm just gonna copy it so we can compare. Okay, so let me write our coordinates here. So this one would be negative pi over 3 1/2. Okay. So the other one would be this one would be 2 pi over 3 negative 1/2, and this one would be 5 pi over 3 1/2. So let me try to bring back my. So check this one, negative pi over 3 1/2 right there. Check this one. Oh, this is this one right here. This one is 2 pi over 3 negative 1/2, and then this one is 5 pi over 3 1/2. So yeah, we're in good shape. Thank you for watching.